All right, guys, we're going to be looking at solving absolute value inequalities in two special cases. All right, so the first thing I want to point out in example 3 is that it says the absolute value of 3 is greater than -5. So if you remember, whenever we have an absolute value, it is always going to produce a positive number. Okay, so algebraically, we don't even really have to look at that this much. We know that x plus 3 is going to produce a positive number. And if we look at the inequalities, here is a positive number is greater than a negative number. Well, guess what? This is always true. Okay, a positive number is always going to be greater than a negative number. But let's go ahead and look at it graphically now, so it makes just a little bit more sense. In order to do that, what I'm going to call is I'm going to say, let's say that absolute value of x plus 3 is called g of x. So let's just type in g of x is greater than, is equal to the absolute value of x plus 3. Okay, and what you'll notice is that graph should form. Okay, and then what I'm going to say is based off of what we have is it says g of x is x plus 3, g of x is greater than -5. So I'm going to type that in. G of x is greater than -5, and the whole screen lights up. Well, why is that? Okay, well, it's simple. It's really simple. If we think about where -5 is actually located on the graph, y equals -5 is right here. Okay, and guess what? Everything above it is greater than. So what happens is all real numbers will produce a graph that is greater than the y value of -5. So in other words, if I could write all real numbers, I can also write -infinity all the way over to +infinity. Okay, so let's go ahead and I'm going to clear that out. And I would say, okay, well, guess what? We know that it's always true. We're going to say for all real numbers. And I'm going to write down an interval notation that we go from -infinity to +infinity will produce the answers. Now, let's go ahead and look at this next piece, okay? We break it down again and we look at it and we say, okay, well, what do I know? I know that this is going to produce positive numbers, okay? I know those are going to produce positive numbers. That's very true. And I have a negative times a positive, which is greater than a positive. Well, let's check it out. A negative times a positive is a negative greater than a positive. Are negatives greater than positives? Absolutely not. This is never true. Okay, negative numbers are not going to be greater than positive numbers. Well, let's look at it, or we could say in this case, since it's never true, there should be no solution. So let's do the same thing. Let's go over to the graph and take a peek at this. And when I do that, the first thing I'm going to do is I'm going to name this side g of x again. Okay, so let's go over to Desmos. I'm going to type in g of x, but I'm going to put a negative in it in front of it because that's all it was right there. Okay, and when I do that, we said it's got to be greater than 7. So let's go to Desmos. Let's make it greater than 7. So it is greater than 7. Is it greater than 7? Notice nothing on the screen actually lights up at all. Check that out. Let's look at it real quick. Well, why is that? 7 is right here. This is the y equals to 7. Okay. And this is saying that it should be greater than, the absolute value should be greater than 7. But what happens? Everything below it where the graph is less than. Okay. And since we are looking for greater than, what we're going to say is this is no solution because it is less than 7. It is not greater than 7. So we're going to write no solution, and we can write a big 0 with a slash through it for that. So let's go back to that answer. We're going to say, okay, what do we know about this one? This is a no solution answer, no solution, or we can write it as a null set right there. Man, I hope that helps you all out today. Good work. Enjoy your math today. You guys are doing great.